Cool. Ready to go? Start streaming, I guess. Connecting. And we ought to be online now. So. Cool. Of course, advertisements are the best. Ah, cool. 0 viewers before we do anything. I don't know if I should post it to program or stream or not. I don't know. I guess I'll come back to it later. Regardless, today's goal is me learning C++. And the way we're going to do that is by writing an emulator, which I have previously written in C++. Well, I'm not going to be using the C++, not the C, which I've written in C#, sorry, which I have not published because it's a horrible, horrible mess. But I aim to redeem myself and make it in C++ instead, which is meant to be more efficient in some way, but well, we'll figure it out. Now, something I'm going to do is, and refer back to constantly, is the Chip-8 technical reference version 1.0. I've also made one myself. I've also made one myself just because I could. And I've also added like notes for the Super Chip-8, which is like a modified thing with more options, which I plan to implement anyhow. So let me quickly. I forgot to drop the link in the description. Total views watching now 0. This is probably going to be a complete waste of time, but yeah. Now, before we continue, Firefox, let's see. C8 tech10.htm. I hope it doesn't kill my CPU, this streaming. No, it's fine. For the time being, anyway. In the meantime, Firefox is really slow. Yep, so I was kind of hoping to get the link to. I was kind of hoping Firefox to show up with my reference guide. Let me look that up again. Okay, so let's quickly drop out of Firefox from here and launch it properly. Okay, cool. So this is the reference I'm going to be using. I have it on my other computer here, so I don't need to worry about that. So the Chip-8 is the easiest emulator in my opinion to write. Apparently it was like a thing back in 1970s and 1980s. I wasn't born yet at the moment, so yay for me, I get to learn about it many years later. But it is rather simple to implement. You don't have a specific timing to keep track of, and so on and so forth. So I guess we can just simply get started. Now, first things first, I'll have to define something that from my last emulator that keeps annoying me is that it was difficult to retrieve the width and height of the display using the length parameter. I know there's get length, but I didn't know about it at the time. So what I'll do is display width, and the width of the display is 64. Define display height is 32. And I'm gonna do this twice because there's also a because there's also a high display mode which we need to use. Cool. I'm just gonna make sections. So we have display width and display height. Now, considering I'm planning to I'm writing this in C and C++ because I'm also planning to port this to my calculator, which I happen to have right here. Last night I made a Starfield emulation on it, and I'm kind of proud of that because it's rather simple to do on a calculator, but you get the idea. So we have the display, we have a keyboard. Yeah, now I think I kind of screwed this up already. So we should start with memory. That should be the easiest. We can always shift things around the we can always shift things around the file as we need to. So we go memory. So this would be a character array. I'm just gonna prefix everything with C8, just So you go C8 mem, and this Chip-8 has 4 kilobytes of memory from 000 to FFF. Yep. Cool. I've noticed this is much slower than memory. Now let's see. And the applications get loaded from hex 200 because the memory before it is reserved for the interpreter. Let's try not to write into that area. I'm probably not going to implement that. I'm just going to let the program insert its own data there if it needs to, but it will probably not be able to access it. So let's go register. So we have the memory done. Let's go registers. I'm probably making a buffoon of myself. So we have C8V, and there are 16 registers. And then we have an unsigned short, which is a 16-bit integer, which we call I, which is mostly used for addressing because it needs to do that. Let's see. There is also a so the VF register is used as a flag. Okay, that's fine. Chip-8 also has 2 special purpose timers. So those would be char C8 sound timer and char C8 the delay timer. Now the delay timer doesn't do anything special, it just simply counts down. It just simply counts down as it needs. Let's see. And then we also have a 16-bit. That means unsigned short. And this is the program counter. which is also known as an executing address. And then we have a stack pointer. So we have character C8 stack PTR. Now I don't know whether I should make this an actual pointer or not. I guess we'll come back to that later. And then finally we have a unsart short C8 stack. No, an actual stack this time. I go uint8 max. I know it has a max. Now that I think about it, we should probably define a maximum stack. Okay, so let's go C8 stack size. Yeah, now that I think about it, I think it is actually a good idea to define an actual stack size. So we go define C8 stack size. We go here, it says 16. Okay, I'll do that. And then it has, yeah, I don't know why, but that seems a little bit ludicrous, but let's just do it anyway. I mean, we have all this memory available to us. Why can't we use it all? I mean, seriously. Stack size. And this stack is probably just for keeping the and this stack is just simply for keeping the executing addresses as the call thing is called, as subroutines are called. It's not really used for anything as far as I know. Okay, so up to 16 levels. And that is about for the registers. Now keyboard. The keyboard is interesting. We've got a 16 key hexadecimal keypad, which I have an idea. How about for that specifically, we could like have a single 16-bit integer and we can flip bits on and off depending on the keyboard thing. So we can go unsigned. So for that we can like go unsigned key unsigned short. Yep, that's what I was looking for. Definitely, most definitely. We have unsigned short C8 keyboard keys rather. Pressed keys. And then we should also have a C8 set key. No, C8 key set. C8 key release. I don't know, I keep having ideas. This is why I haven't made the header file before the C file. So we go press release. What else? Oh, we have one person watching. I wonder who that is. Weird. Is it just me? Probably. C8 key. Get. Retrieve. I know bulls aren't a thing in C, so I'm just gonna make it a char. Or, I know it's a thing in C, but I'm thinking for more embedded systems it might not be a thing, because for a fact that the C implementation that this calculator uses, it doesn't have a bool. So what I just simply do is just simply assign 0 and 1 to things. So we go here. Cool. We can implement those functions later. I'll just simply declare them now. Let's go. Keyboard should be fine now. Display. Now the display is going to be quite interesting because I don't know whether I should make one array or two arrays. And there's another issue where we have to like change the different arrays. Let me think. How could we possibly implement this? I know in C# we have a garbage collector, and we can like resize and remake arrays as needed. But I know that it's something that keeps me, I can't say keeps me awake at night, but you know. For the time being, we'll just simply make a char array. So we go C8 display, and we're gonna go make a one that is C8 display width. Inside that C8 display height. And the reason we're declaring those as constants, and I screwed up this time. And the reason I declared those as constants is because the best as I know, is just C++ doesn't really have a get the size of array thing that we can use. So we go char 8 C8 display, C8 display width, C8 display height. We're just going to do that, and we're going to go void C8 display set char x char y char bit. I'm going to get a char display get char x char y. Now I have done some very similar implementation for I've made a similar implementation for the Conway, for a Conway Game of Life simulator, where I didn't have enough memory to store each bit in like a byte, because that is horribly inefficient. Let's go display. We also have these wonderful numbers which we have to lay into memory at some point, which we'll do as we initialize the emulator. Now let's go timers and sound. So we go timers. We can move these from here down here, and then we can have like a function called void timers. So we go C8 timer tick, which takes an absolutely nothing since it just simply takes the timers. And finally we get to the fun part, which are the instructions. So I'm just gonna go here, which are the functions, which are the, yeah, you pretty much know what I mean. 13 views. I wonder if this is gonna come back and bite me. We never know. Now let's go have, why don't we include the C8 emu file, copy this into that, because pretty much everything here is a declaration, so there is no real point in doing things this way. So we're just going to include the C8 emu here with all the declarations here. and then we can like go actually implement them. So let's take a quick look. So we have memory registers. Now let's go CPU and void C8 CPU cycle. Boom chakalaka, and we can now like, and C8 CPU cycle will effectively do everything. Now, when it comes to eventually making the graphical user interface, and so we can interact with this wonderful C8 virtual machine, we already have that set up. Now we also have to initialize some sort of game. I'll figure that out later. And it's still raining outside. Yay! So let's go implement things. Let's close this off to the side. Let's bring this off to here so you can see the functions we have to implement and what we're implementing for. Let's just simply run make. Yay, no bugs here yet. I just also included here. Cool. Ooh, first defined here, multiple definitions of. Okay, I have no idea what this means. There are multiple definitions. Oh, I see. So all I have to do is just implement them. I'm just gonna keep that for IntelliSense to pick things up, and then we can like figure everything out later. So let's do this. So we go C8 CPU cycle. It's a void, if I remember correctly, and we can go write it. So so we need to like split the. It will be much easier if we pre-calculate all the n and n over the bits of the instruction. So look into memory. Actually, no, it's that simple. So we go get upper and lower bytes. This will make it much easier when it comes to implementation. So we go char k. No, is it kk? Yep. Char kk. It's an 8-bit value. It's the lower 4 bits. Okay, so go char up. So that would be C8 mem at C8 PC, and we go C8 mem C8 PC plus 1. Now all the instructions on the Chip-8 thing are 2 bytes long according to the document here. So we can go char. Ooh, 2 people are watching now. That's cool. So we go char n, which is from the lowest 4 bits of the instructions. This would be kk and 0x0f. Now, what that end does, if you think about it, you have like if things. So it's like if. So we have like it can like mask things. So if we have like a very interesting function, an instruction, it's like, I guess I can't explain it. It's just a tongue twister. Well, not quite, but ooh, 3 people are watching now. That's interesting. So if you go back to the implementation, and the x value is the lower 4 bits of the high instruction. So this we have up and 0x0f. Now kk, and we go shift 4 bits to the left, and make sure we only have one like nibble, and we already have n, so we have, now we need n and n, which is a unsigned short. We have an unsigned short, which is this, and then we pretty much all we can do now is we have x, bump it up 4 bits to the left, and then we add the lower 4 bits. So it's like, yep, Shift X, like add 4 bits. Like, I really can't explain it, to be honest. It's just, it makes sense in my own head, but I don't know how to explain it without some sort of whiteboard. Idea for next time around I'm doing this. So you go. Cool, so now that we have all the pre-calculated positions, we can like go for the each address. So we go, oh, it's also a good idea to have like the upper 4 bits, because we can switch on that and it'll make life much easier. So this we go 4, make sure we cut off any information we don't like, and that's nice. So you go first 4 bits. Now, for those interested, there's this document. So we can like do this. I'm also going, now if you scroll all the way down to the bottom, there are these additional instructions which I plan to implement at some point, but not now. So you go switch on first bits. So this will go switch. I don't know why it leaves a space there, and then we go U constant expression. That's fine, 0x0. And then we can go, well, there are a couple of 0x0 things. So for example, there are many instructions that start with 0x0. So we have 0x0 NNN, we have 0x0 0x0 0e0 and 00ee. So it's basically, we can do like if NNN is larger than 0x200. Oh, yeah. Implement some way to execute native code. This sounds like a stupid idea thinking about it now, but hey, it was done, so I thought I might as well implement it. Hold on a second. This is incredibly dangerous. Can I do this? So you go, preceding any parenthesis, a parent call must have a pointer to a function type. Wait a second, let me quickly check Wikipedia. Because Wikipedia has the resource on everything. Here's what Wikipedia does have. Wikipedia has some example C code on how some of these actually work. So yeah, Wikipedia has some examples on how this actually works, and I'm thinking of like C sudo. Okay, so I should be able. Yep, call subroutine and. Why is it not letting me do that? I'll just leave it at that, and oh wait, duh. I wonder if make complains. Yep, make does complain. Yep, not make. See the compiler. I'll just leave that as a curiosity for anyone reading the source code. Is this person actually crazy enough to actually go on with this? Yes, I am. So let's go NNN equals E0. This is display clear. I'll deal with that later. So we go else if NNN. I could also do a switch case here, but then this would be a bit of a pain. So we go 0x0ee. Now this is pop the stack, and yeah, so what this is, it pops a stack and then it goes and saves it. Where is it? So I need to think about this all over again. I hope. So we have. So I need to think about this all over again. So we have the stack, and we're currently pointing to the previous address. We're currently pointing to the previous address. Now, if we decide to like return, we drop one. So we return it and then we drop. So we go C8 PC is C8.stack, and we go C8.stack PTR, and then we decrement after it's been accessed. So that tends to work. Let's also do. There are some extra ones down at the very bottom, so I thought I might as well implement those. Let me get down to it. So we have sed nibble. So we go else if nnn. 5 people watching now. Thanks a lot for finding my content relatively interesting. So we go. I have my own reference file which I have made, but it's not finished yet, and there are a lot of gaps and mistakes in it, which I need to do before sharing with everyone. So it's down to the super Chip-8 instructions. Where is that? There they are. And so we go if the address is now go 0C. Oh wait, no, that doesn't work. Well, we can do it we can do it x equals c, x equals 0, and c and y equals c. And then we can do scroll. I can't type today. Display n pixels down. Else if and 0 fb. We can go scroll pixels, 4 pixels left. I don't even know why I need to put these else if. That cannot be right. 0 fd. Oh, fc. I could just copy paste this. And I still haven't installed the insert plugin. Stupid me. Yep. Someone switch attempting to make an emulation of a CPU life. I can't say it's an emulation of it. I can't say it's emulating a CPU specifically, but it is a virtual machine of a Chip-8 of the Chip-8 standard, which is similar. This is just simply a beginner project for me. This is pretty much the first time I've dabbled into proper C++ development on desktop. I've done some small scale projects until now. I've done some small projects until now, namely a Starfield emulator. Not a Starfield emulator, Starfield on a calculator. And I've been attempting to make a Pong thing on that calculator as well, but it's working in an emulator, but it doesn't work on the actual hardware. So low resolution mode and high resolution mode. I have yet to find out what though. I have still have to find out how to do the low resolution, high resolution changing thing, and I'm still not intent on having like two separate, you know, and I'm still not intent of having two separate things. Now I finished the first bit. Now this is gonna be the part of, this is going to be the really annoying part where we have to implement the functions, the different instructions that the emulator is doing, and this takes quite a while. Luckily this emulator only has like 46 instructions in total, so yay. Cool. So you go to the one instruction, which is relatively straightforward. It just simply says this PC, the program counter, to the specific address. That is nice. CA PC. Now this one is the now 2NNN. I should probably comment all of these. And I hate it when Visual Studio Code does this. Come on. You're not that stupid. No. There you go. So you go 1NNN and jump to address. And we have this one, which is 2NNN. Call the address. Now for the call thing, we have to push the existing thing onto the stack. So the way we took it out is by first okay, so I'm doing it the way it's doing. So since to return from a function, or subroutine in this case, we have to like set the address to the top of the stack and then subtract 1. We have to do the opposite. We have to add 1 to the stack, so C8 stack pointer, we have to add 1 before, and then we have to make sure it's within the stack size, because otherwise bad things happen for no good reason. So you go increment the stack pointer, make sure that is within the stack size, and then we set that to the current executing address. I go C stack, no, PC, and we set the program counter to the requested address. So yay. Now, oops. Cool. So we go SEVX byte. Okay, 0, 3. Okay, now this one skips the next instruction if VX is the same as the byte. If the specific register is the same with the byte that we go here. If X is KK, we go. Okay, we increment the program counter by 2. And that is nice. Oh wait. Yep. Oh shoot, I forgot to put break at the end. Because that happens. So you go 4xkk, which is skip if not equal. VX byte. Now that I think about it, I should probably disable ligatures. So case if X is not KK, Now I myself prefer ligatures because it looks nicer, but I understand it's not everyone's cup of tea, as a friend has told me. Now this one is interesting. So we have 5xy and then we have 0. But even though there's a single instruction here, that which is 5xy0, let me highlight it for you. So even though there's a single instruction that follows this format, there you go. There is a possibility that other emulators, other Chip-8 emulators could use this, like could extend this 0 to something else. So this is interesting. So this is the question mark means it's yet to be defined. Now, because I want this emulator to be expandable in the future, if someone decides to add an additional feature, we can have like if n equals 0, we can add the functionality. If we want to do something even grander, then we can like keep going. But for now we only have that, so we have hang on, I just realized something. This VX here is meant to be a register. So we go V X. Now I pretty much know that the X there is going to only be like 4 bits because because of the mathematics we've been doing. Well, mathematics or bitwise logic, I don't even know. So we go, yep. Now for this one, we go 5xy0, which is skip the next instruction if the register vx is the same as vy. So this is a simple. Now a lot of the stuff in a lot of the work you do in an emulator is basically understanding the hardware and writing it in a way your current hardware would understand. Now, by writing this into C, you have the possibility to like port this to any number of computers or systems that support C. So we go so compares Vx to Vy, and if they are equal, then increments the program counter by 2. So I didn't even need to put these brackets here. So you go program counter plus equals to 2. And then finally we have to break because it's a case. Now the 6xkk is load Vx into Vy. I don't know if I should have like given a precursory look at the instruction set architecture of this. Yes, it is. I prefer ligatures in my. I prefer having ligatures in my source code because it makes things look slightly more mathematical, you could say. So if you take a look at this, I'll just get rid of this for now. If you take a look at this not equal sign, I'll just bring the settings here. If we take a look at this not equal sign, if with ligatures on, it looks like how it look as if you write it in maths or calculus. But if I disable that, if I can find the ligature, but if I disable that, it looks like a regular C++ code thing, which is, in my opinion, pretty interesting. Oh. And it's buffering on my end. Great. It could be, but I'm not sure about that. I'm just gonna have this bigger for now. Yeah, it does look like a multiplication sign, and yeah. So we go now. LD actually stands for load into the LD stands for load into something, and that something is the VX register. So yeah. And then we go 7xkk, and this is now starting to get more and more interesting as we're going through the things. So, and this is actually starting to look more and more interesting now. Yeah, so you go vx equals plus equals kk. Now ooh, we have another one of these mixed ones. Great. Yeah, I understand. I'm looking at the Twitch chat over here occasionally. Sadly, the screen I've attached to my secondary computer isn't all that good. As in, it's a square rather than widescreen. So, the 8x stuff is getting, like, we have like a lot of mini functions, and from what I understand is just the ones that the instructions that start with an 8 are generally for maths things. So we go, why am I doing that? So k0x8, go break, and then go if n is 0, load vy into vx, and then it's also good to have opcodes. Now it's just a case of implementation. So this is like else if. I don't know if the else if is needed. It's probably not, but it's just a habit. If things end up breaking when I get to testing out the actual thing, then you know, they'll be fun debugging. I don't think I even have a debugger for this. Now, if I remember, the thing for or is that, yeah. Now, what I like about C style languages is that they have so many shorthands. They have quite a number of shorthands for things that you need to do quickly. And yep, oops, 2 C8 VX and that. Yep, so and that. So you go C8V Y. I can't wait to get some games and test this. So you go XOR. I'm still very much mystified by how XOR works. I mean, it's a really useful tool. It's especially useful when you need to flip a bit for any reason. Oops, that's a V, not a Y. I have been misled. Oh no, this is my least favorite part. Well, it's not overly complicated, but it takes slightly more effort than I'm accustomed to. So we basically have to determine what if what we're doing has a carry. So we're going to create an integer. We're going to call it result, and that is obviously going to be vx plus vy. And then we're going to go C8V0xF is going to be if the result is larger than the maximum of an 8-bit integer. Luckily, C has a prefix. Luckily, C and C++ have a prefix for that. I mean, I could do it myself, but You never know. And so we go, okay, CVX is going to have the results stored in it. And hopefully it will do the clipping automatically. And so 5 sub. Now this one is going to be a little bit simpler, so we go vxvy else if n equals 5. Now this is slightly simpler because we only have to do 2 things. So 0xf is basically what is going to return a not borrow. So it's basically if it doesn't borrow. So if vx is larger than vy. You're absolutely right. I'm sorry about that. Thanks for catching that out for me. So you go C8 V is X is larger than Vy. that is actually great. The more I keep going, the more I do this, the less I regret doing this, because I'm not a people person, so to speak. Now, the very interesting thing about this command is that y is effectively ignored, which is both an interesting thing and also quite a bit of a waste. But it still makes for slightly cleaner code. So what the SHR thing is slightly different. So basically Vx, if the least significant bit of Vx is 1, so pretty much V0xf set Vx equals 0. So basically we're going to do V X and 1, because we only want the least significant bit, if that makes any sense. And now we go, and then we have to divide by 2. So X needs to be divided by 2. I'm just gonna align this. Don't forget the comma at the end, semicolon. And then we're going to do 0xy7. So you go sub n vx vy, which basically is a reverse subtraction. So instead of subtracting one way, we subtract the other. And so we go ca p v 0 v, and now it has to be if vy is larger than vx. So we go c8 vy is larger than c8 vx. Now we go c8 vx is c8 vy minus vx. Cool. Now, for some bewildering reason, we jump straight to E. So that'd be C8V 0V. Wait, no. Yep. So if this time is the most significant bit, so this would be like. So if we have like 8-bit, that'd be like 2 of these things. Now we shift 1, 2, 3, 4, 5, 6, shift 7 and 1. Cool. And now we do x equals C8V. And then we multiply by 2. And I forgot to put the comments here. I don't know what these, I'll be perfectly honest, I don't know what the SHL and SHR instructions are for, but, you know, things are things, apparently. Now we finished with 8xy. Let's get on to 9. And is 9xy 0. Okay, so k0x9 break. If n is 0, we can go, let's see, if n is 0, then it's 9x by 0, skip if not equal. So if C8V equals x is not equal to C8V y, then we go PC plus equal to. So C8V is yep, so hang on, let me quickly bring up the header file. So I set it to a unsigned character array, or character array short quickly, and that is because, as far as I know, uint8t isn't really defined in C. Well, I could give it a try, but I remember trying it. Yep, it comes up with a thing here, is not defined. So that's why I picked it. That's why I picked char over the yep. Try including std int. Yep, the main issue I've got with that is let me see. I've noticed that in a number of things. Hang on. Let me double check that quickly. Std int. The why Chip-8 would be interesting to see someone implement their own VM with its own language. Well, that is actually a good question. I was actually interested in doing something like that when I was learning how to like write this stuff. When I was like learning how to write this, and I'm thinking of doing something similar, but keep it down to the lowest, like to keep it down to like the lowest possible thing. I mean, I don't know if Chip-8 has been done to death or not, but I mean it's definitely an interesting look at it. So yay, I guess. So yeah, the main reason, back to the SlashLifes. Oh, that is a very good question. I'll come back to say that. See, yeah, I've come back to. I'll come back. Char is not guaranteed to be 8-bit. Of course, test char bit from limits. Yeah, use uint8. When using assigned type over an yep. Yep. I'm writing this in C because I'm actually I'm looking to port this to my calculator at some point. My calculator being a Casio FX, so this thing, FX 9750 G2, which for which I have installed the firmware from the next model up, which allows me to write software for it. So if I can, I'm just gonna take a quick break here. So where's wine? Here's wine. So if I bring up the development kit, it'll probably not work because the development kit has quite a bit of a problem with 64-bit systems, and I've got a 64-bit wine prefix installed. So let's see. I don't want to open up the C file. Yeah, an issue I had. Yeah, so this is pretty much the thing I'm going to be targeting at some point. Nah, not really. They kind of have. We basically have to prove that we've wiped our calculators at some point. To well, not at some point. We have to completely wipe our calculators as we step into the exam room. So there's kind of no reason to like cheat. Well, it's not like there's no reason, but what I was trying to say is there's no way we could possibly cheat it. Like, yeah. If you know what I mean. Not to mention, if you're gonna cheat anyway, what's the point in going to school? So, you know. If you're not the best way to cheat school is to actually learn the stuff. Wow. That could also work. I could cheat the school and get a job instead. I wish I could have done this earlier, to be honest. So you go, case. So we go. Yeah. So 0xa. Now for 0xa, we have to do with the memory pointer integer. Yay. So we go C8I. That is actually a good question. I do need to check that. So I'll just go in my program file here, which is at this point a simple hello world. So you go printf. Char size. So you go C8 emu. Wait, what was it? Char bit from limits.h. Let me see if that's also available in the. Yep, it is. So char limits, char size. So we go char bit. So we go make. Yay, default. What is it? Expected primary expression before default. Where are you? Yep. I'm just gonna. Yep, I know exactly where those errors show up. Or not. Segmentation fault. Where is that coming? Where is the segmentation fault coming from? Oh, you. Yep. Char size 8. Yeah, I just realized S is for string. Yeah, and I'm used to like I usually write in C sharp most of the time, so I'm used to like right line this. So I'm used to stuff like this, not actually. And if I needed to change the, yeah. So yeah, I'm used to like doing this stuff, and if I needed to change the formatting of things, I just simply do toString and specify. Yeah, that's no excuse. You're absolutely right. I'm still learning, and everyone makes mistakes. That was simple enough. When are we going to get to the fun bit? BNN jump to address relative to v0. So it's PC. Unacceptable shame. I know, I feel it. So you go PC is NNN plus get the value of C plus V 0. Because there's no reason why you should have anything else. There may be, but I'm not sure of that. Random time. Okay, this should be relatively simple. I know, see, I watch the I watch a YouTube channel called Bisqwit. He did a very similar project, but I'm going about it a clearly different way. So yeah, and I've noticed that the random device for C++ is slightly different. I mean, you can still use the same function. It's just, I don't know, it just simply had quite an interesting impression on me. Now we're going to get the, oops, what was that? Get a random integer and we clip it to the and then we're going to like set it to the maximum, and then finally we're going to end it with the byte. So that'll be KK. No, not the C, not the PC. VX. There we go. Break. The I register is used for memory. So basically, if you've it's basically used to point at memory. So basically, when you're referring to, you could like, hang on. I don't think we've gotten to those register. I don't think we've gotten to those instructions yet. But I is used for memory locations because it's larger and it's larger. Yeah, so basically, let's say you want to draw a sprite, which is actually the next instruction. So I guess I'm gonna go ahead and do that. So let's say you have a so basically what the I thing is, what the I register is stores memory for the time being. So for example, in this draw function, which I'm about to write right now, what it basically does is takes a look at the hang on, I'm trying to word this. What it does basically stores memory. So for example, for a number of instructions like the draw function, it could look up I to find where the certain sprite is. You should put this massive switch in a separate header SMH. Hang on, let me quickly look that up. Shaking my head. Yep, I know. May seriously, Sid Rand. Okay, how do I do that? How do I do that exactly? I know the main program. I know the main program is somehow. Somehow. Okay. Yeah. According to the wonderful document I have printed out here like a couple of weeks ago. I only have like a rand max. According. Yeah. Well, you know what I do? To do. Find a better bloody way to gen numbers. There we go, much better. And I'll be bothered to this until no end. So D is drawing. So what D? So to draw things, we have to look up a n size sprite in memory, and we have to put it on the screen relative to the dx and dy. Still see rand. Yeah, the question is, how do I do this exactly? Because rand, as far as I know, rand doesn't have any overloads. Get time of day now. srand. Is there an srand function? All I get is GCC have sync and compare. First go srand and then rand. Okay, right now Visual Studio Code doesn't give me any hints for srand. I just simply get GCC compare and swap. I'll just simply put it as a memo for when I come back to like debug. That is actually fair enough. That is actually fair enough. So I'm just gonna take a note here because I have to I'll implement the display separately. Yeah, precisely. This is not meant for cryptographic stuff. It's meant for games and small programs that run on Chip-8 architecture. This is why I have game development on it. Well, this is why I put the game development tab to begin with. So dross and size sprite from address I at point vx vy. I'll come back to this function later on because it is a matter of implementing the display, which I prefer to do last, because if I can write the emulator, the core parts of the emulator first, and then if I write the GUI for it, you could say, then I can come back to getting it to work. So you go ex, this is one of the this is one of the mega ones, which I generally don't like, so we're going to go break. Luckily things aren't as painful as they seem. I'm just gonna do this for now. And then we go fx. Yeah, dev random. That is also a very good idea, but I kind of want this to be like kind of cross-platform. So we'll see how that works. In the meantime, I could possibly do it for the front end override. I could possibly look into overriding the random function at some point. So you're going to go 0x0a. If I can type properly, that is. And if it's default, then by this point something completely horrible must have happened. Okay, jokes aside, now I can see the E section is for keyboard stuff, so keyboard stuff, and we can start with EX90, which skip if pressed. Now this is where I disagree with how the documentation does it, but now if skip if keyboard press, so get key retrieve. Let's see, key retrieve, this should return 1. If it returns 1, we skip, so we're going to go X. Cool. If that, the program counter can go 2. I'm just looking at the wonderful conversation in the chat. I should probably install the chat plugin for the I'll look into installing the chat plugin for the for Visual Studio Code, but I don't want to like show my Twitch auth ID or whatever they use for logging in. Key retrieve. Now this should be a not C8 PC plus equals 2, not plus plus. Why is it expected a semicolon? What do you mean expected a semicolon? There's a semicolon right there. Make expected a semicolon before if. The hell? Your if. Oh, else if. And skip if not pressed. So you go, and now we have the huge XF stuff we need to do, which is fun. And go XF, and this is the first one, and then we go if KK is 0x0. Wait, no. Hang on. 0x. That. What does this function do? Oh, it starts with 0.7. So 0.7, and that does LDV load the delay timer into the VX thing. Oh, okay, that actually makes a lot more sense. Okay, so yeah, the previous implementation I was doing of this, which was in C#, I just used that because I was using switch cases, which, as it turns out, is not very good if you want things to expand. So let's go back to the documentation. I'm going to do C8VX equals C8D dt, which is easy enough, but this one is going to be fun. Now I should also probably, let's see, program counter. Now I should also probably go C8 execution paused. But now that I think about it, it's just keyboard is a fine mess I need to deal with. So you're going to do fx. Now what I'm talking about is the upcoming thing, fx ld vxk, which holds the execution and then holds the execution temporarily until a key has been pressed, and once a key has been pressed, then oh wait, no, that is a lot easier than I think. Then I would. Now that I think about it, it's a lot easier to implement. So, yeah, the previous implementation I've done with this was like 1 year, 2 years ago when I just learned about the thing, and then I kind of dropped it because I didn't know how to draw things on screen. Yay for me! So let's go vx. Okay, so this and if C8 keys isn't 0, or probably not V8 keys, because V8 keys is going to have some sort of value. Because the way I've decided to do the keyboard is by having a single 16-bit integer, because this computer thing has a 16 hexadecimal keypad, so I just simply go 0, 1, 2, 3, 4, 5, and the different bits, so I can just simply shift the bit that I want, and I could return it. Now the reason I made this function is just so it's easier. Because, you know, more concise, it's important to have concise code, apparently. So you go vx, and that would be the key that is selected, but so we go C8 key retrieve. I have to find a way to implement this. Come back later. Don't forget else here, because that's also important. Come on, we're on the last stretch of the first round of debugging. So we go LDDT, VX, and we go LSIF. And so we go LDDTVX. What is it? LDDT. Load the delay timer. Delay timer. Okay, so that's easy enough. And then we go FX18, which is LDSTVX, which sets the sound timer, which creates sound, which sadly is not quite possible everywhere. 18. So you go C8ST, C8VX. I go FX1E, add IVX. Now I go else if one E, you go C8S, wait, no. Okay, so I plus equals Vx, and that is C8I, not just I, because that is just plain stupid. Vx LD FVX. Now I'll come back to this later because this loads okay, LDF. Well, in my opinion it should be LDD, but actually no. LDF makes perfect sense because it could stand for font. When I take issues, when I take issue with the documentation this originates from, I just simply go and do it. Loads sets I to memory location of X character of built-in font. FX33 ODB. Now this should be D because it stands for decimal. VX else if KK 0x33. Now I kind of wish I had I'm probably not going to build a disassembler in this thing, built into this thing. Now this is decimal. Actually, no, this should be easy to implement, but SlashLife decimal representation of VX, and then finally go that, which is LD. Oh no, it's not finally. There you go, LD IVX. Actually, no, I'll just simply go store. And this should be easy enough. 0x55. Here we go. Store register 0 for VX starting from memory location I. So we go for I equals 0. I is less than n. Plus 1. No. Less than or equals to n. I plus plus. And so we go mem. We go C8I plus I equals VI. So we go finally FX65 LD load VXI. And so we go for I equals 0. We do pretty much the opposite thing. Okay, cool. So we now get into the territory where I could write anything I want to do with C++, which is the front end. Oh wait, no, this is the header file. So you can go program.cc, and we've loaded SDO. Let me quickly look up the SDO reference real quick. Cool, so let's go get started. So let me quickly look up the reference. Yep, we've got SDO. Now let's go create. A surface pointer for C8 screen. Yeah, well, I do have a C++ compiler, but it's not debuggable, and it will be a pain in the bum to set up. So now this is the part where I have where I have pretty much reign over my Linux computer, and I can do anything I want. Yep. So SDO surface. Why is that coming up with red? Exactly what I thought. So we can go like load the emulator. Okay, I'm not planning on running this yet, but we should load stuff into memory. Let's go get some games. Chip-8 ROMs. Can we get some ROMs? We've got a Pong ROM. I'm still slightly disappointed. You can't just simply download parts of a GitHub repository yet anyway. And only now I've just realized I had a set of games already downloaded, and I'm still stupid enough to go through it. Fun times. Let's go program.cc. Let's go look ROMs. Did it do it? No, it didn't. Yep. So let's go load some. Let's go, before we even think of initializing SDO, let's just load the ROM. load there are no games to be played. Don't bother. So argc includes the executable. So I think I'll go argc isn't 2 because you will only need the executable plus the thing. So if it isn't 2, fatal. You have met yourself with a predicament. What were the color properties again for Linux? Let me quickly go bash colors, because it should also in theory work in C++. In theory, that is. They're just simply escape characters. Ah! I'll take a look at that. System exit. Return EX usage. Cool, thanks for giving me that tip. And don't forget the new line at the end. Let's compile that and give that a try. Make. No target. Oh, wait. Of course, I was in the rooms folder. Okay, where did I go? Rand is not. Rand was not declared in the scope. Why is that, I wonder? Does he define E? A pretty Make didn't complain about it yet, so that'd be math. Let me quickly check that though. Math. No, math doesn't declare it. stdlib does. So let's go C8 emu. Yes, you have met yourself with a predicament, my boy. It's either you haven't selected game yet or you selected too many. So we can do just that now. So let's make again. Cool. So let's go make sure now load the selected game. Into a buffer for the time being anyway. Now Now if I go uint 8, yep, uint 8t is definitely yeah, so uint 8t is definitely declared in C++, so that's not a worry. So we're going to go buffer, and now the size of a Chip-8 ROM should be like 4 kilobytes minus the now this something I forgot to definitely include is that the initial no, not the initial, basically the starting address is 200 is hex 200, so let's definitely do that. This would be PC, and we're going to just simply specify it here because there's no reason for it not to be 200 to begin with. So you go create a buffer. Okay, so include fstream, I think that is. Now this is pretty much the first time I'm going to do this in. Now I haven't really done any file work in CPP yet, so I'll do that now. So name space D, and then we can go. I think we can go ifstream. So if I go ifstream in file, I could have done that earlier. Stupid little me. And then we go in file dot open, and then we can go argv1. And if it's not the case, unable to open that. So I can go ex. Let's take a quick look. STD binary. What is that exactly? Let me quickly look that up. All I can see is that they know 2 file handling modes, text and binary. Okay, and how would I do that? Exactly. STD IN. Oh yeah, I get that. Second parameter to IF stream open. So if I look that up, so you're going to go IF stream open. Open mode. I see what you're talking about. So if I go to wrong keyboard. Oh, I see what you're talking about. STDIN. Should I also include IO stream? STD has no member binary. All I get is these three. Oh. Oh, cool. Okay, so iOS, not ISO. Okay, so if the file doesn't exist, this should show a fatal error. Let's give that a try. It's taking longer and longer. Yep, thanks, Albie. So you can go. So let's give it a try. So totally not existent file. Cool. That does it. Cool. So okay, so if it would be while in file to X, so you can go like something like. My question is, how do I go about iterating this? Is this going by byte or is it going by something a little bit more? So int X. Oh. So it'll be ifstream.read. Cool. Let's go read. Okay, so there's an example program here. So I have string bin. Let me see. So wait, does this calculator not have programming mode? I'm disappointed. Let me figure this out. Much better. I'm just gonna take a page from someone else's thing. Yep, obviously. I'm just gonna take a page from someone else's thing. Okay. I'm just gonna find. I just found a function that could possibly work, but I'm not sure. So read binary file. Yeah, but I don't want it to be a vector. I wonder how many people agree. I wonder how many people agree with me on this. Half of a programmer's job is googling. Me and a couple of friends were joking about that the other day. I'm just gonna copy this code and see how it works. So data. Vectors are not initialized. Could it be that? Oops. There we go. F stream. You're absolutely right about that. Yep. Yep. Binary. Binary IO dot open file name. iOS in. iOS binary. iOS trunk. I'm not sure about this trunk here, but I'll just leave it in for the time being, and if it causes issues, I'll take it out. Okay. Nice. Binary IO read my data.data. Okay. Okay, so the original thing is unsigned int, from what I gather. And so we have in size, binary IO, strunk, size of that size, resize, read the data, and then value type. Actually, that buffer pass to read, it require reinterpret constant. I never actually thought this would be as troublesome as I thought it is, to be honest. I've seen another similar thing in the past, so that would be something like, hang on, C file. I'll look into the old-fashioned file descriptor. That actually so infile read buffer fill. What I do there? So that is so that would be instead of the read. Cool. Let's give that a shot before trying the old style. Yep. I'll try the thing you sent in. So that'll be I'll just do it here and file.read buffer size of buffer, and then we can go std.fill buffer. Hello, Michael C. In file telg. What is telg? Buffer plus size of buffer, and then ends with a null character. Parentheses. Argument type. Okay, let's just do an array of char. Let's see if. And I forgot to close the parentheses here, haven't I? Cool. Telg. Okay, that makes a lot of sense. So we have a buffer. Now I'll return here for testing. So let's see. Return. And no, I can't just std out. Okay, that makes perfect sense. Perfect sense. Yep, in this case the workshop charge elements are bytes. I think the read might need a reinterpret, but we'll see. I'm thinking of printing this out. So let's go. I can't use printf. So see out. This will probably be a bad idea, but if we can pipe it, like pipe it to hex dump, that could give us like an idea. Oh, fun times has no value. That value would be 0. That's fine. Ooh, now I get a number of nodes. Ah, that is an error. Where is it? Ah, it's in the function. I have never bothered. It's in the function. I never bothered to finish it off. Make. Okay, we made it. Now, if we do totally non-existent file, I don't worry. Okay, that's fine. ROMs. Pong. And let's pipe it to hex dump. Nothing. Okay, what is that about? Yep. Yep, so far it just simply prints out absolutely nothing. I'll also do something very stupid. Oh, see how there's a formatted output. That stops at a null byte. Which I have a sneaking suspicion that it is wrong. Come on. Whoa. Yeah. Huh. So it can go. See how the right. Make. And then if we go. Okay, now it just simply prints out a bunch of zeros. Yep, I noticed it. What it does now is just simply print out a bunch of null bytes. Let's take another look. So we have file open, it opens its in. Well, this is useful and all. I'm just gonna. Yep. Let's give that a try. If that doesn't work. Yep, it prints out something, but it prints out quite a lot of things. Cool. And I wonder how it is. Okay, so it prints out this, which includes quite a bit of extra data from what I can see, compared to the actual Pong file, compared to the actual ROM. But let's see how it looks. Yeah. Okay, so I'll just open both the ROM and the HD ROMs Pong, and then we can go to less, pipe that to less, and then we can like, okay, cool. So Yep, it does. Yep, it does do that. And since the game has doesn't really have a lot of reason to read beyond that. Yeah, and since the game doesn't have any reason to read beyond those bits, I don't think it'll be as much of a problem. So, cool. So I can make like region load file, and we can get rid of this. Now, end region. Cool. We can now do region initializes DL and region finish. Well, I don't think there's a reason to finish. So we have two regions. We kind of finished with the loading file. I'm gonna leave initializing SDL for the time being. I'm gonna load the ROM into the RAM of the emulator. So we can go for int I equals so we can go like define C8 mem size show x that go program.cc, so we can go like I equals 0, I is less than C8. No, that's not selected. C8 mem size minus. Oh no, we need to start with x200 since the starting x. Yep. And then we can go, okay, so we're going to go. I think it's G count, not tell G. Yep, makes sense. Does it? Hang on, I'll check that at some point after I finish this. And then we can go like C8 mem I equals to buffer I. We could look into making this more efficient, but later. So yeah, load file. I guess I'm gonna go ahead and I can't speak today. I'm gonna go initialize SDL. So where is that? At. Cool. So we have a screen and we have a C8 display surface. Wait a second, am I overwriting the one in the header file? I hope that is not. I so hope that's not the case. Yes, I am. So we can go change this from C8 display to game display. Because it's not good when we override stuff. Let's see. Set up the screen. Create a surface for the game display. I don't want that as the. I want this. I don't want the content management company. I want the simple direct media layer. Go 1.2. And let's jump over to the documentation. Cool. So let's look up name and category. Yep. I'm usually used to like quick repeated testing and development, but with an emulator it's not really possible now, is it? You kind of have to try out the bulk of the thing before you even try test it. So where is it? API by category. I want to drop pixels to the surface. So we go put 6809. Is it that? Ah, I see. Yeah. The 6809. So like the CPU, the 6502 has like ripped off or something. Or was that the one? Yeah. Um. SDO surface, I know that, but blend surface don't need that. Create RGB surface. Let's take a look at those. So set up the screen and surface. So we can go game display equals SDL dot surface. Can I just use new on it? No. Oh, it has data fields. But how do I go creating a new one? Yeah, how do I go creating a game display? It's SDL create RGB surface. Cool. So we have flags. Flags are unused and should be set to 0. Okay, that's fine. And what the width of the surface is C8 display width EX. The reason I use the high resolution size is because if it's in the low resolution, we just simply need to double up the pixels, which is good. Depth, that'd be 32-bit. And I assume I wonder, can we just simply like ignore? Too few arguments in a function call. But how about null? Can I just simply do null, 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 null? There you go. How many masks do you want? Sheesh. let's see, create now we're down to the less interesting part, which is just debugging and doing things. Okay, so this should be just 0, 0, 0, 0. I'll just leave it at that for the time being. See if it breaks anything. And then we can do a SDL. Well, not just an SDL, but a loop here. So you can do while true. Let's see. So I go loop here while true. While true. That much is true. Events. Let's see. Okay, so we can go like well, here in the tutorial I'm looking at, its critic was false, but I could just simply break out of it if that's kind of the case. So let's go. Well, there's an event to handle. Okay, so we can go. We start the main loop while SDL poll event. Yep, there's no event. That's the thing. Cool. We've got that at least. And it's still raining outside, which sets for a nice, wonderful afternoon. Event. Okay, cool. So we have while that, we can go if event.type equals SDL quit, not SQL. SQL is a completely different thing, computer. And we go, okay, we can break now, and this should clean up. So this would be SQL free surface game display. We go SDL.quit. And we should return to OS nicely. I could possibly look into putting the different things into a vector, but terminal processor exited with code 127. That doesn't look nice. Anyhow, let's go make. Oop, what was that? No, 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 no. Yep. I should just simply put zeros here. Happy now. Make. It's gonna give me. It's gonna complain about things being defined multiple times, but I thought I did say in the header files that if this is not defined, define it. But oh well. If any of you, if anyone watching this knows what's up, then right here. Wait. How is this a failure exactly? Weird. We have multiple definitions of things, which is not good. So we have a definition for C8 emu here, we have a definition for the CM8. So the header file, I just simply said if it's not defined C8 emu, define it, and then go through everything until the end of the very bottom. And let me quickly show you the make file. It's very simple. It just simply puts everything into GCC, it links SDL, and it just simply takes in the program and the C8 emu file, and then it just simply squishes them down into one executable. So yep, that's, and then yep, I have the program which is in C++, and then there's the emulator interpretation which is in here, and then there's the header file which contains all kinds of definitions for, I guess that's self-explanatory. Yeah, that's what. Copy those variables, put an extern in front of every variable, and so just simply copy them to. So copy the. Okay, so I'll copy this into here. So, and get rid of this, and just simply plop extern in here. Cool. Only the variables, not the functions. Okay. I'll get rid of the functions when I get back to them. I don't really understand why. I don't. Well, I do kind of understand why there is like. I understand why header files exist in principle, but I've coming from like C Sharp and C JavaScript. I'm going to just simply look up the definitions in the file. Yep. I know this sounds really stupid, but I'm just curious. Yep. Are there any other functions? Let's take a look at the outline. Yep, the display. Okay, so we have the memory, which is here. We have registers, which have no functions, and then we have the keyboard, which only have the keys functional. We have the display stuff, only variables. Cool. So in this one, we only have what we barely need. Cool. Make. Warning, initializing declared extern. Ah, okay. I see what you mean. Yep, it's declared and it's an extern. So It's only just a warning, but it still has two definitions apparently. Okay, let's give that a try. So ROMs, and that would be Pong. Cool, we have a window, and we can handle the quit event. That is not working. Oh, no, is it? No. Why is it not handling the event? And it's not even letting me quit. I was under the impression that if that was to quit. Okay, task manager. Well, except it's not called task manager, rather than system monitor, but you get the idea. It manages tasks. So C8 Emu, kill it. Yep. Come on, put it out of its misery. Kill. You're breaking from the interloop. Inner loop. Yep. Yeah, my question is, yep, I don't think we're going to need to do this. So it just simply goes back. Okay. Now, I think we can just simply pull the event as it is, because in theory we can, and just simply get it immediately afterwards. So pull for SDL events. Pong. Now, of course it's not going to emulate anything yet, but at least we can quit. So, yay, we now pulled things. Now the question is, now let's make this look nice. So, we can have like, what? Oh, I should probably move these a little bit forward. Cool. So we can now void. Now, does SDO when you just simply like blit if you just simply blit a surface onto something, nah. Okay, so let's go find a font. Small. I remember looking up a font like a couple of days ago, but I remember looking up a font a couple of days ago. Yep, that's the one. Okay, so whoever made this font, hang on, I know this is under the, okay, so, okay, Brian, here's a CC, here's the Creative Commons accreditation you need. So, let's see, so there are two versions here, which are slightly different, which is absolutely fine. Now, this could be used as a sprite sheet and used as a font, I guess. Wait, do I need to use it, or can I just simply use the SDL font libraries? We have stuff like frame rate, but we don't have text. Great. Let me see if I can find anything with apt search. SDL font type TF. No. Okay, I'll be using the spreadsheet then. So it's blown up 4 times, which I do not like. I'll say that right now. There's SDOTTF. I know about that. Let's see if Synaptic has anything on it. So let's see. SDO. Let's just look up TTF and see if SDO comes up. Fonts, free font TTF. Lib free type is installed. Apparently SDO-TTF is installed, but I'll just look it up again. So include SDO-TTF. Oh, found it. Cool. Yep, now it's time to look up how actual SDO-TTF actually works. So yay fun. Yep, I've got a bunch of TrueType fonts installed. Now speaking of TrueType fonts, when I installed Linux on this computer like a couple of weeks ago, I forgot to do one thing, and it's in the name of font compatibility or something like that. I don't know. Something that I think it's missing with a lot of Linux. Something it's clearly missing with Linux distributions is a universal font selection, and I can't fault the distribution, the people who make the distribution make it happen, but I think this is one of the reasons that Linux is not really all that it can be. It's just people kind of get hung on their beliefs. Hey, but you can still download the Microsoft fonts for free, so hey, who am I to judge? I'll refer you to the quote Markiplier used for his on his FNAF thing. Cool. I'll just install my fonts for now. So where was I? Unzip Microsoft fonts and rename this. Career News, the best font ever. I personally have to disagree, but hey, you do you, man. You do you. In terms of programming, in terms of fonts for text editors and whatnot, I prefer Fura Code because it has those wonderful ligatures. But on the side of terminal usage and whatnot, I prefer, and a general user interface font, I prefer the IBM Plex series. Creator surface for the game display. I've already done that on the line above. Roboto is also good. It's just, for me, kind of grew boring over time. It just became boring over time, and I couldn't be bothered using it anymore. It happens. Um, Something I don't really. Oh wait, no. Cool. Um, yep, that is not the first reference. That is not the first time I heard that joke. Um, so far I have made a Chip-8 emulator in C++. I mostly come from a C sharp JavaScript Python perspective perspective of things, and I thought I'd try something new for the time being. So, and I finished the kind of behind the scenes low end stuff of the emulator, and I'll work for the time being. I'm working on the user interface, and I'll go back and finishing off the emulator afterwards. Um, I don't know why, but I have a feeling I should ditch SDL for N curses or something like that. Because, I mean, I don't know. Should I ditch SDL for N curses? Even though it's not the first time, even though that's not the first time someone ported this terminal, this emulator to the terminal before. Um, yeah, I'm planning to. I'm looking into making my own assembler for my own assembler and disassembler combo for it. And curses for sprites. Well, the way the Chip-8 works is that it has a bitmapped screen, like a with this a 64 by 32 bitmap screen. You could also put in a high resolution mode where it effectively doubles the resolution. But the way sprites work on the Chip-8 is just simply they just simply XOR they just simply overlay the sprite over it, and then if there are any collisions, it will like knock those bits out. Not to mention why not write your own compiler? Well, what did I say with writing my own assembler? I mean, I do have like a dream programming language. I would like to make at some point, but and I know some of the basic structure of how it could work, but that I'm still like learning a lot of the stuff. So yeah, if I was going to do it, I'll probably not do it in C++. I'll do it in a language I'm more familiar with and I have more control over, like C sharp, for example. I don't know. Everything is like a programming challenge. Well, I'm not very familiar with C syntax, and I still have to discover quite a lot of algorithms that could be used in the future that could be used to generate things. I mean, it's just a case of, hey, I'm learning, I'm at school, and I want to learn more as time comes, and it's just, hey, how about we do a practice? Write your own programming language and your own compiler for x86. Mm, I still don't know a lot of x86 assembly right now. I've been yeah, I don't know a lot of x86 assembly at the moment. I've I've looked at real mode programming at some point. Um, real mode on x86 hardware before, and I found it pretty interesting. But yeah, that's I'll take a look at it at some point. Yeah, the main reason I'm doing this is because I'm working on a computer science paper for R links allowed. Well, I haven't gone out and disabled them, so as long as it's not like malicious, it's fine. Welcome to the chat room. So, yeah. Writing stuff for embedded devices is also cool. Speaking of, yeah. Speaking of which, I do actually have a Raspberry Pi here, and the other day I was curious about could I get an SDO game work on can I get an SDO game work in the console? Yeah. I do actually have to agree with that. Poor security standards are a problem. I do actually have a Raspberry Pi here, and it's connected to a CRT TV. I wanted to make like an 8-bit style Commodore game system thing that I could toy around with every now and then. And I've been playing around with it recently, so that is actually pretty cool. Hmm. Yeah, that sounds like fun. Cool. Now I can't find any. Well, I can find like references, but I can't find how to use those. I can't find how to use the TTF library. So you can go like TTF. So you can go SDO TTF. Examples. Okay, so I'll go back to trying to figure out my head around um, SDO. SDO. I mean, how fun would it be if I could just simply chicken out? Okay. So I've got constant SDO version, linked version. Okay, so I could like declare a font. So load consoles as the font TDF font pointer. TDF. Oh. Font, open font. Something that I can't say is a lot of fun is that can I use a system font? No, I cannot. Okay, that's fine. Can I just simply use font and just refer to the font? Oh wait, no, that is just simply. Okay, so I literally have to open a file. Okay, that's fine. Okay, so open font. For the time being, I'm just gonna go. I'm just gonna go ls user share fonts, Microsoft fonts, true type, Microsoft fonts, and then we can have console.ttf. And I go copy, I go paste here, and then after that we have point size, which is like 12, let's say, for example. And we go close font, and we get close consoles. Cool. So now to draw with fonts, we go so SDL fill rect SDL surface, that would be screen. SDL rect. Now how do I like declare SDL rect as a thing that I could immediately use? Let's think. So we can go SDL rect. Oh, wrong keyboard. Can I just do this? So let's see. Oh, so it needs the pointer. So it basically needs the pointer to the rectangle. I have no idea how to do this inline, so I just do this. Hang on, can't I just simply derive a rect from a surface? Let me quickly look that up. Surface, screen, clip rect. I assume that will work. And then color. Color. So it's B. So it'd be like RGB, and I have no idea what the last bit is. If it's going to not work, then it is not gonna work. So I wonder if that'll work. So blank at the window. Let's make no target spec. Oh, of course, because I have to pop the directory. Make undefined reference to TTF inet. Okay, make file time. So we go SDO TTF. Can I just do that? No. Okay. What is the SDO TTF thing? You need to put in a variable so you can take its address. Yep, I kind of realized. I was kind of thinking, well, I guess, yeah. I mean, there's a clip rec thing, which we'll see if it works. Now the question is DO, how do I include that? I'm just gonna have a few blind guesses before flailing. Link. So I was on the right track, it's just I didn't capitalize things properly because Linux is case sensitive. I have no problem with case sensitiveness, but okay, so let's go. Okay, so let's make it a variable then. So we go SDO rect, and then we go. We're just gonna use this rectangle just because. So we're just gonna create it, and then we're going to go rect width. I'm curious about something. I'm really curious about something now. So we go. Okay, so we go screen width. I can't type. Decimal. So we have size. It does not need to be a pointer. You're right, but yeah, you're right. And if you do have a pointer, you need to know it. I'll just do this for the time being. So I'm curious about how the screen. Okay, we can do that, but I'm curious about the rect here. How does this work exactly? Weird, it doesn't give me any more information. Okay. You win for now. A width is screen width. Is it safe to assume that if I have a uninitialized variable, that the uninitialized, if I have like a, if I initialize, if I just simply create a struct like this, is it safe to assume that the values I haven't explicitly stated myself are like undefined or something like that? Make maybe I should change 00 here at the end to FF. No, oh wait, I didn't even compile it. It's still black. Oh, yep. Yeah, but I don't think it really matters. I'll see if I'll set X and Y and see what different that makes. No, it's still black as night. It's still as black as the night. You need to assume, in your context, you need to assume that those values are uninitialized. Yep. I'll just. Yep. Just as you said that. I still haven't, like, UB. Screen. Rect. We have an H. Yeah, but I want to fill it with white, not black. I need to see the edges of the. I want to see the edges of the game display, as it were. SDO surface.src, so I'll just go with no here. Is there any way to, like, define structs inline in C++? I'm aware that C is a little bit. I know that C is pretty picky when it comes to inline initializations. Oh. This could also be my issue. But here it asks for a uint, not a color struct. I'll just give the struct a try. Okay, so color. Okay, so let's try define it in line. So STL rect. Yep. So if that is the case, ideally the API would, like, put things in order. Hopefully. Let me scroll down to the version I'm using because the documentation they have is slightly newer. Okay, so in terms of the SDO rect, it's probably width, height, x and y. No, x, y, width, and height. So, yep. There's still no way to take its address. You're completely. Yep, that makes a lot of sense. So if I go back to color G, well, if I can define this inline, I can just simply do color. I can do 255, 255, 255, 255. What is the last one in color? Ah, it's alpha. And then it complains at me. There's no suitable conversion for this to that. So map RGB sdo.map RGB, and we can go surface screen dot format. And then we could do 255, 255, 255, 255. And everything disappeared from the chat room. Fun. Times. Oh yeah, too many. Stupid. And it is still white. Very much white. It comes with an integer. It comes up with an integer with that, which I will assume is the success rate, which is not the case, which annoys me deeply. Oh look, it's around lunchtime. I will work on this for 30 more minutes and then I'll take a break. Do I have to blit the rectangle? Okay, so according to the no pointer. Okay, I'll give that a try. Doesn't complain much. No, it still doesn't do anything. Okay, so it asks for a SDO surface pointer and then a constant SDO rect pointer. And then finally it asks for a color of a certain type. So use this function to perform a fast fill of a rectangle of a specific color. Okay, so we have destination, which is the SDO surface structure that will be the drawing target. SDO rect structure representing the rectangle to fill, or no for the to fill the entire surface. I'll go no there. The color to fill with, see remarks for details. Okay. Return 0 success or a negative error code on failure. Call SDO error for more information. And then the code example over here. Which one is the displayed surface? Okay, so so there are two surfaces at the moment. There's screen and get display. Screen is the screen, unimaginably. I can't speak today. And the game game display is the display which the Chip-8 display would be mapped onto. So I guess yay for that. So yeah. So the way, pretty much the way I got it so far is pretty much the same as the code laid it out. So we have a surface, and then a surface has been created through the create RGB surface thing. I'll go ahead and try do the game display surface just as a test to see if that turns white instead of the screen like I want to. I know it's being blitted afterwards onto the screen and still nothing's happening. And this is happening in the initial like launching stretch, so yeah. I can't quite understand why it wouldn't work, but okay. Now remarks. Color should be a pixel format and can be generated by that. So that apparently is the case for the thing. Apparently that's how it works. Apparently, I am incredibly stupid. I just realized why it wasn't working all this time. Well, it is true that we have been putting things onto the thing. We have yet to flip the screen. Yep. I feel very foolish right now. Yep. This was incredibly stupid. I forgot the one thing that actually updates the screen. Far out. So, hey, at least it works. Oh my god. I have become incredibly annoyed now. Okay. Oh well. Let's go render that text. So ttf render text. Is that a struct font? And so we have the SDL color, which is the foreground color should be black, which is about that. And then the background color should be SDL. Yep. Okay. RGB, and then the background should be white, ideally. Cool. Too few arguments in function call. What do you mean too few arguments in function call? Expected type specifier. Okay, so now we have the address of the font. Wait, what? Is the font already a... Yep, the font is already an address. That is static. And there needs to be an STL color. Cool, we can do that in place, so yay. That sounds good. Too many arguments, why is that? So we just need the foreground. Okay, cool. And now how do we, now does this effectively become a surface that we can build? I kind of hope it is. So okay, so it does become more or less of a surface, I think. Yep, so we can do like screen, SDO build surface. And so we go source, I go text, and then the rectangle. No need for that. Destination, that would be the screen itself. And I'll just go null for now. And we can just simply go, okay. When it comes to this split, then we can go stl rect. And that would be like 10x, 10y. And I'll just go null here. Can I do this then? Yeah, SDO rect does have to be a thing, can't it? Oh well. I guess that's why we have a single rect variable. So x equals 5 rect, y equals 5. I can go rect width can be the game display width, and rect height can be game display height. That is rectangular. And we do need the address of the rect, don't we? Cool, so that works. Make go. Oh, cool, we've got some text, even though you can barely read it. That's fine. We can like shift this a bit down. So we can go Y. We can like shift Y a lot more down. So 15. That didn't help. Make cmu rums. Cool. We do have like a little display. I mean, we'll probably blow it up a bit more. I sound a little bit like I sound like someone. So rect equals y to rect w is text. Okay, so it's a pointer. Of course it's a pointer. Text w rect dot h equals text dot h. I feel like I've learned a lot today, to be honest. And I still forgot to put the rect here. The address of the rect. Yep, I think I've learned quite a bit today when it comes to C++ development. So we have a little teeny tiny display over there, which is cool. Which is also not very useful, but hey. Something I'm rather curious about is that font is not anti-aliased, which kinda annoys me. Let's see if there's anything that can be done about that. Okay, so solid is quick and dirty. I probably picked the wrong one. Then we have shaded, slow and nice, but with a solid box. Slow, 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 but ultra nice over another image. Okay, we're gonna go with slow, slow, slow and nice, but over another image. For the time being, well, I could do shaded. Shaded could work, and now FG could just simply be set to white because it can. Let's give that a go. Cool. Now it looks a little bit more respectable. And it's no longer aliased, which makes me very happy inside. Let's go for another trip around the moon. That makes literally no sense. Let's see, what time is it? I've got 10 minutes left. So 10 minutes left, and then I'll take a break. The 0 pixel value is the background. Okay, so I've obviously made quite a bit of progress over here. I've learned a lot today. I could use this. I've learned a lot today. I can't say I haven't. Cool. Let's keep going. So let's go make a run. How many Chip-8s have you made by now? 2. One is in C#, one is in C++. Because, yeah, if when I did in C#, it was in the terminal. It was in the command prompt, because C# has really easy command prompt setting management. But I've noticed that once I ran it on Linux, it started like doing stuff that wasn't meant to do. When I tried to run it on Linux and Mac, they did a lot of things that they really weren't meant to do. For example, it's just Linux and Mac do consoles quite differently than how Microsoft does theirs. Microsoft has each character is just simply a color. It just simply has a color and it just simply has a color and an attribute. But it just simply has a color, 2 colors, foreground and background. Whereas with Linux, you have the console overall has a color, has a foreground and background color, and you can also specify other colors on top of that, as I did over here. And it's like you have a lot more choice and customizability and you can also specify like 256 color codes if you really want to. Now, where was I? Yep. So I'll take a break now, and maybe when I come back I'll make up a memory display and do a little bit more debugging before just signing off for overall, because I've got other things to do today. Sadly. Thanks for the maximum of around 9 to 10 people who watched this. It was really fun, and hopefully I can see what other people have said in the chat. So, hopefully I'll come back.